Hey, everybody. Oh, I should probably mute. Let's try that again. Hey, everybody. My name is Alex Merced. Welcome to this open source data deep dive. This is the second one of these events that we've done. We did one about a month ago in New York. These are great events to talk about just really the amazing open source technology, the open source technologies in the data space. Now, basically, just, this evening we have three talks. So first, I'll start off by talking about the Iceberg REST catalog. Who here's excited to hear about Iceberg? Raise your hand. Yeah, I love seeing hands raised. And then after that, we're gonna have Yufei Gu talk about the Polaris catalog. Who here's excited to hear about the Polaris catalog? Yeah. Okay, and then after that, we're gonna have Waymo Liu talk about graph queries on Iceberg. Who's excited to hear about graph queries on Iceberg? Yeah. Yes. Okay. So now we got all that like stretching done, right? Okay. Good. Because it's a Wednesday night. I was about to say Thursday night. See that I travel a lot. Okay, but as I mentioned, we're gonna be doing a raffle at the end of this. So after all three talks, I'll keep collecting these cards throughout the evening. But we're gonna be auctioning off 2 copies of the Apache Iceberg Guide, both autographed or signed or however you want to think about it. And then we'll also be doing these Starbucks gift cards. Okay, so lots of chances to win stuff as a sign of our appreciation for supporting the open source community. So thank you all very much. But with no further ado, and hopefully for everyone who's watching online, hello, we will begin with our first talk. Okay, so I'm gonna set up back to the main page. Okay, and here we go. I'll just kind of go over here into this over here and be like, hey, everybody. Again, my name is Alex Merced, and I'm gonna be doing this talk right here, the Iceberg REST catalog, making catalog interoperability happen. Okay, but before we get started with the feature presentation here, let me just kind of introduce who I am. My name is Alex. I'm a senior evangelist for Dremio. Okay, basically, one of the things I've spent the last 2, 3 years doing is going all around the place, writing everything I can, and helping people learn about the data lakehouse, about Apache Iceberg, about Apache Arrow, about all sorts of different technologies to kind of enable the sort of new world of really being able to take your data lake and make that the center of your data universe. So I've spoken a lot of different events. I got the which was an amazing experience. I got to be one of the co-authors for Apache Iceberg, the definitive guide. So I spent a lot of time thinking about this, and a lot of time reading all those emails on the dev list of seeing all these conversations that great devs like Yufei are having all these conversations about new things in the Iceberg spec and being like, oh, that's a really good conversation. Like that's really interesting. And if you haven't signed up for the dev list to read it, you really should. Some people read, the newspaper in the morning. I'm reading the Iceberg dev list in the morning with my morning coffee. But in that case, if you want to get a free copy of the book, you can get a free digital copy by scanning this QR code. It's also on those cards that were on there. So if you have flipped the card, you'll see there would be QR codes on there as well for this to pick up a copy of the book. I'm also currently doing an Iceberg crash course where I'm going over like what Iceberg, a lot of the stuff you'll hear tonight and a lot more, which you can sign up through this QR code here. If you're not already tired of hearing my voice by the end of tonight. But there's that. And again, all this will be recorded and posted on YouTube. So if you don't scan it today, we'll make sure they will message you guys so you see where you can watch this again on YouTube and get access to these QR codes. So don't worry about missing a scan here or there. As you can see, I talk a lot. So I also host a bunch of podcasts where I talk about data all day. Okay, whether I'm talking about modeling, whether I'm talking about data lakes, whether I'm talking about open source, I got a podcast for it. And then we also do this by about once or twice a month broadcast called Gnarly Data Waves, where you have all sorts of different guests from all over the data lake space come and talk. So that's who I am. So now that we know that, let's get into our topic. Okay, and if we're talking about Iceberg and if we're talking about REST catalog, well, there's a couple things we probably should establish first, because we need to understand sort of like, okay, one, what is a catalog? But we don't need to know that until we know what Iceberg is. And well, for me to know what Iceberg is, I need to know what a lakehouse is. So let's start there. What is a data lakehouse? Okay, and so hopefully we'll kind of just set the base for all the other presentations this evening as well. Well, to kind of really appreciate what a data lakehouse is, we need to understand what came before data lakehouses. So when we think about it, up till now, generally when we work with our data, we work with our data in two primary systems, databases and data warehouses, which are amazing. We love databases and data warehouses because they do some amazing things for us, right? They figure out how to store the data. Okay, when I use Postgres, I don't have to think about how that data is stored in there. It just does it for me. Okay, and then when I create a table in Postgres knows how that table exists. Like, how does it know that there's table 1 and table 2 and table 3? It figures it out. That's all abstracted away from me. I don't have to think about it. I just get the experience of that system. Same thing with how does it know that there's 10 tables in my particular system? Okay, it has a catalog that tracks all the different tables that I have within the system. And then on top of it, I can write some SQL. And that SQL then gets processed. Like that SQL gets parsed, gets turned into an execution plan, and that plan gets then executed. Okay, and this is all well and good with databases and data warehouses. Databases oftentimes for like transactional processing. So we're talking about like row-based data. And then when you're talking about like data warehouses, we're actually oftentimes talking about columnar data that's going to be better for analytics. But either way, these systems are essentially abstracting all this way for us, giving us a experience to work with our data. The catch is that each one does it differently. So in that case, if I want to use multiple systems, I have to make multiple copies of my data. Okay, so that can get really expensive. And then two, also that means every time I move my data, that's one extra step before the data gets to where it needs to be to get the insights that I want to derive. So wouldn't it be nice if just all my tools could just talk to the same data one time, instead of having to make 50 copies? Only if there was a place that generally I could store data that everyone could access. And there has been that paradigm. There's something we call the data lake. Essentially, you could use something like an S3 or an ADLS. Generally, anywhere you could store data as files, you could use it as a data lake. And essentially, we could run queries on the data lake. Okay, you could either do it with Hive, which was like sort of like the past standard. You could use a tool like Dremio to run queries against things like Dremio, AWS Athena, to run queries directly against your data lake. Okay. But the problem is this sort of data lake paradigm, there's a couple things missing. Where's the table format? Where's the catalog? These things are important so that way when I use a tool, again, name your favorite query tool, how does it know what tables exist? How does it know that it is a table instead of 1,000 Parquet files? Okay, that's like the abstraction layer that's missing. Okay, without knowing that, hey, these 1,000 files are one data set, there's all sorts of optimizations I can't do, all sorts of things that are just not there. So you don't get that same performance as you would in a data warehouse. Well, what if we added those layers back in? What if we took that storage layer, again, your S3s, your Azures, your Hadoops, your, name your favorite storage layer. We took your favorite compute tool, but we just throw in there a table format, some way to identify those 1,000 Parquet files as a singular table. Okay, and then two, a catalog that tells us, hey, these are the tables that exist. Okay, suddenly now you have that same level of abstraction, but you now have it in a layer where basically multiple tools can be swapped out at different parts. So instead of having to have a copy of your data for each tool you use, you have one copy of your data. You can use all your favorite tools. You can go run queries against your data lakehouse using Snowflake. You can go run queries against your data lakehouse using Dremio, whatever tool that you like. That's the beauty of it. Basically, you have your data and you can use the tools that you like to get what you need done without having to worry about making more and more copies. So that's a data lakehouse. Now, Apache Iceberg fills in that specific role of a table format. So again, what the table format's doing is just basically saying that, hey, this group of files is table A. This group of files is table B. Okay, and that's fine. But Apache Iceberg and other table formats, they go a step further. They don't only just say, hey, these are the files that are part of the table. They provide you statistics. They provide you additional metadata that allows you to then scan those files intelligently. Okay, basically, if I know that, hey, these files have this data, without me having to actually read those files, I can determine whether I need to scan those files at all. So I have 1,000 Parquet files, and my particular question only needs 30 of them. Wouldn't it be nice to skip scanning the other 970 and just scan those 30? Okay, and that's the beauty of Apache Iceberg, where you have this you have this whole metadata layer, and I'll kind of go over this, I'll just kind of lay it out first. Okay, you have this whole tree of metadata that allows an engine your favorite query engine to kind of efficiently scan that table on your data lake. And typically the way this would work is you'll have a catalog. We'll talk more about different catalogs throughout the evening. But the catalog essentially is, think of it as like your phone book. So not that you see phone books as often as you used to, but what would happen is like if I want to know, well, hey, where's Bob? What's Bob's phone number? I would open up the yellow pages. I would look up Bob, and next to Bob was the phone number where I can find his number.
White pages.
Huh?
That was white pages.
You're right, the white pages. If I want to look for the pizza place, I go to the yellow pages. There we go. But either way, I'd get that big book, that big thick book, and I'd go look up the number. Okay. In the same way, the catalog acts as that directory. I go, hey, I'm looking for table A. Where is the metadata located for table A? The catalog tells me. So at minimum, think of the catalog as the yellow pages for your Iceberg tables. Okay. We'll continue to get deeper into catalogs as the evening goes on. This is going to be a very lot of talks about catalogs today. But when we actually find the metadata comes in sort of three layers. First is the metadata.json file. Think of this as like the top of the pyramid. So if I'm a tool that's querying this Iceberg table, this tells me what the table is. It tells me, hey, what's the schema of the table? How is the table partitioned? What are the different versions of the table or snapshots of the table? Okay, so that way I can have an understanding of the table as a whole. Now, then what's going to happen is I'm going to determine, hey, which version of the table I'm trying to scan, because it keeps track of the history of the table. So we're going to assume that, hey, I want to scan the newest version of the table. So in this metadata file, it's going to be a listing of, hey, which is the newest snapshot? And the snapshots are stored in the manifest list file, okay? Which is where like the words can sometimes get a little mumbly because I'm saying manifest a lot. So a manifest list is a list of manifests. So I'm going to kind of step forward to the manifest, explain that for a moment. So there are files that make up this table. And so what's going to happen is that we're going to list those files in groups. So each group of files that make up the table are these manifest files. So each one may have X number of files that are part of the table. And each row listing those files is going to have stats on those files. So let's say we're talking about a sales table. It'll say, hey, this has a total sales value of this range to this range for this file, this range to this range for this file. Okay, this date range for this column in this file. So we'll have all these stats on those files. Okay, now the manifest list lists all the manifests that belong to that version of the table. So there might be 100 manifests, but for that version of the table, this current version of the table, only maybe 30 of those manifests actually belong. And then we roll up those statistics into that manifest list. So the cool thing about the manifest list is that it actually has stats for each group of files. So now I can actually do what's called partition pruning and go through each group, each manifest, and say, this manifest, I don't even need to look at. It doesn't even have data that I need for this particular question or this particular query. So imagine I have 30 manifests that list, let's say, 1,000 files each. Okay, so we're talking about like a bigger table. Okay, I might be able to skip, let's say 20 of those manifests. So I skipped 20 files. That's really the equivalent of skipping 20,000 data files. Okay, and I was able to do that pretty quickly because I'm doing it directly from that one file. And then I would just scan the remaining manifests that weren't already eliminated and take a look at the individual files and then can eliminate that. So the idea is that the metadata allows the engine to kind of go through a file skipping process to determine, hey, these are the files that I truly need. Because the less files I have to even open up, the less file operations I do, the faster the query. Okay, so that's essentially like the really, really, really cool thing here. So essentially all this metadata acts as like an index that's attached to your data. So not only are you getting a table, but you're getting this large index that's attached to it that allows for efficient querying. And that's why you get that data warehouse-like performance right there directly from your data lake, which is super cool. Okay, the more I think about it, the more excited I get. Okay, I know some people get excited about like the big game on a Sunday. I'm excited about like, oh, look what the metadata can do. Okay, because it is pretty cool. Okay, but then once you go through all that metadata, you can then scan whichever files that are in storage that you need for your queries. And now you can actually have really fast queries directly from your data lake, and multiple tools can follow the standard, apply the standard, so they can also scan the data. So that's the beauty of it. I can have one copy of my data, it's going to be fast, and I can use multiple tools to access it. That's pretty cool. But as I mentioned, you need that whole phone book thing, right? You need that thing to track your tables, because basically, how is your tool supposed to figure out what tables you have if there's no phone book to tell you where that metadata is? So that's what the catalog does. So as you can see here, you have query engines. So think Snowflake, think Dremio. They go through the catalog. They're going to ask the catalog, hey, I'm looking for table A. And then they're going to point to your data lake storage and say, hey, that's where you can find that table. Okay, that's the role of the catalog. Now, how do you do this? So essentially what a catalog is doing is specifically not pointing to where every metadata file is. It's specifically pointing to that top file, that metadata.json. So it's saying, hey, here's the address for the current metadata.json file for that table. Okay. So like you see here, every time the table changes, a new metadata.json gets created. Okay. So right now this table's changed 3 times. So the catalog is pointing to the newest one. Okay, because theoretically, if you change your table, which probably happens, change, like frequently, like think of a streaming data, you might have thousands of these metadata.json files sitting in your storage. Okay, how would an engine know which is the right one for the right version of the table? The catalog. Okay, now how does it actually mechanically do this? Well, there's really 2 sort of big buckets on how it approaches this. Okay, the first way is the file system. Okay, this is sort of this is generally not recommended for production. It's oftentimes referred to as Hadoop catalog, which is kind of misleading because it's not just for Hadoop, it's for any file system. But basically what it does is that instead of you having like a running service with all your other metadata files, there's a file called versionhint.txt. In that file called versionhint.txt, there's going to be the name of the right metadata.json. Wonderful. So what's going to happen? Every time the table changes, you have to update that file. But not all file systems are the same and provide you the same guarantees. So that's the challenge here. The particular file system you're using may not have the same kind of concurrency guarantees when you're changing a file. So you can run into potential consistency issues if you have multiple people updating the table at the same time, and then this thing is pointing to the wrong metadata.json. So it's typically not recommended for production, great for experimenting and trying out Iceberg. But just so you understand how mechanically why you hear that when you read the documentation and things like that. What you typically do for production purposes is you'll use some sort of service catalog. Okay, and what a service catalog is you have some sort of running piece of software. So this could be something like an Apache Polaris. This could be something like a Nessie, a Hive, Glue. There's a variety of different options for what this catalog can be, but it's a running service that the tool would then make a request to. So let's say, like Dremio would make a request to whatever catalog you're using, and that catalog usually actually has a backing database. So there might be Postgres database behind it, or whatever database behind it, which has locking mechanisms and those ACID guarantees. So that way, when you update the reference, you have those guarantees backing that catalog. So in that case, that is definitely the right metadata.json file. Okay, doesn't matter how many people are trying to update the table, you're in good shape. Okay, so that's typically what's recommended, that you use some sort of service. But having this catalog, we eventually had to develop this thing called the Iceberg REST catalog spec. Why? Okay, so let's first talk about the problem that existed before. So from a developer standpoint, okay, originally when Iceberg was first created, there was the Java API. So basically all the libraries to do Iceberg stuff written in Java. So if you had a tool that was written with a Java or any kind of JVM language, you could use the Iceberg libraries. So the idea was, if you have your own catalog that you want to use, you just write a Java class that would be that catalog. So that works. Okay, you'd have a library for Hive, a library for Glue. You create all the different classes you need for using those catalogs. That's fine. Problem is the project expanded. Now you have PyIceberg, so that you have a Python API for Iceberg. You have a Rust API for Iceberg. You have a Go API for Iceberg, and probably in the future there'll be more in other languages. So if you kept that paradigm, what would happen? I would then have to go back and rewrite that class for that catalog in Python, then rewrite it again in Go, and then rewrite it in Rust. So then this creates kind of a disparity of hey, which catalogs are available across which language. Also, what would happen is that catalog was oftentimes chosen by the client. So it wasn't chosen by the tool doing the query, it was chosen by if I was configuring Spark,
to do a query in Iceberg, I'd have to say, hey, this is the catalog I'm using, and here's a library to use. Problem with that is, what if I'm not using the right, like the newest version? So there's versioning issues. And then on top of it, if you're using a managed platform, so you're using something like, let's say, like a Dremio or other managed platforms, they're the client, and they would have to build in which ones they support. So maybe the catalog you use isn't supported by the tool that you're using. Okay, so this creates all sorts of different like sort of complexities, when the whole goal here is to make things simpler for people. Simpler when you don't have to make 50 copies of your data, but we don't suddenly want to introduce this new complexity of, hey, does my catalog, am I using the right version of my catalog? Is my catalog available for this tool? That just adds this new layer. So that was the problem. So then they came up with a solution. And the solution is the Iceberg REST standard. So this was a REST API standard. So essentially the idea is that we go through, hey, what are the different things you need to do with the table? Let's create a standard for what a REST API should look like to do all those different table operations. And now any existing catalog and catalogs that will exist in the future, they can apply that standard. Okay, so instead of everyone having to create their own version of a catalog, we just all apply this, create the same uniform REST API. How the backend is implemented could be unique for each catalog, but the requests that the client have to make is the same. So in this case, I could have 10 different catalogs, but I can use the same Java library, the same Python library, the same Go library, the same Rust library. Okay, instead of having to have 10 or like one library for each catalog in each language. Okay, and that makes life a lot simpler. Because now if you're, again, a query platform, you can just say you support REST catalog. As long as you build support for the REST catalog, any catalog that supports this specification now works with your tool.
Under the hoods, the table, like an RDBMS need would still be there.
Again, it depends on how each catalog can decide their architecture. But the idea is that you don't have to think about the connectivity. Long as you apply the standard, your catalog can be connected by tools that support the standard.
Like I can use a REST client and connect it, but under the hoods, whoever implemented it, in order to ensure that whatever the
More than likely, there'll be some sort of RDMS or some other storage system. But again, that's going to be unique to each. So theoretically, there could be implementations that might not use a backend database. But it's not implied. The REST specification doesn't imply how you handle the things in the back.
It's about how you retrieve. That's
It's how you communicate those requests to the service. So it's like basically the way I would think about it is like languages. Like for example, or actually like think of it like a pizza menu. Okay, like or really a menu for any restaurant is essentially an API. I can ask for any of the things on the menu. Okay, if I call a pizza place and I go ask them for like try to think of a non-pizza place thing. I barely even eat pizza stuff. Huh?
Burrito.
A burrito. I ask the pizza place for a burrito, they're gonna look at me funny, right? Because I'm not asking for them for something on the menu. Okay.
You can ask for stuff on the menu though. Sometimes they have it.
Yeah, you could, but I mean, but the idea here is that you have a set menu of things that you can ask for, and everyone agrees on what that menu is. And because of that, all the tools can program for the same thing on both ends. The clients can agree, the servers agree, everyone can talk to each other without having to create several different implementations. And that's the beauty of it. So for example, if I were to create some new tool tomorrow, all I have to do is build REST catalog support, and now Polaris can be connected, Gravitino can be used, Nessie can be used, all sorts of different catalogs can be used right out of the box just because they build support for REST catalog, instead of having to build individual support for each of those catalogs. And that's makes life a lot easier. So now suddenly, if you're someone who wants to create your own catalog tomorrow, if you support the REST catalog, you already have the ability to connect to all these tools. Or if you're a company that has specific needs and you build your own custom internal catalog, you have support with all your favorite tools. And that's the beauty of it, because I think like Netflix has like their own custom catalog that they build in-house, and they use the REST catalog spec to connect the tools.
Like that it's a support like a JDBC type specification.
Correct. Is it very much in the same way that JDBC creates like a uniform way to connect databases? This creates a uniform way to connect to your catalog. So very much in the same way.
So that whole concept of the blue catalog, Nessie catalog will go away?
No, there's still different catalogs. It's just the same connector. So then you won't need multiple connectors to connect to different catalogs.
And it still means that if I create a Nessie catalog, it would still only be read by Nessie catalog, not the blue catalog.
Well, okay, so yeah, so you still only talk to the catalog you're connecting to, but I don't need, like if I have for Nessie and Polaris, I don't need to create two connectors. The same connector can connect to both. So whichever catalog you're using is no longer going to be a blocker for which tools you can access.
So it's basically whatever I put in the connection on what sort of host or,
Correct. It's just a
or
way
the
of talking.
plugins that I put in.
Yeah, so I'm just creating like a standard way you talk, not a standard for who's on the other end.
But are all catalogs pledging to support this? For example, Nessie, Glue.
Nessie supports it now. Glue, I think, is working on it. I think for the most part, everything is moving in that direction. And for open source things like Hive, chances are there'll be proxies that'll be created over time. I would say every catalog I'm aware is moving in that direction. And then every tool that I'm aware of is moving in the direction of supporting it as a client. So it's definitely now the standard. Now, the standard can change, like the specification may change, and I think they're working on a V2 of that specification that's going to introduce all sorts of new endpoints. But we're probably half a year from that. So we'll cross that bridge. But yeah, so that's the beauty of the REST catalog standard. So you have lots of tools that can support that standard, and this is just a small selection of those tools that can support the REST catalog specification. And then you have catalogs that implement the REST catalog spec, and if you can use any of these catalogs, so here you see Nessie, Gravitino, Unity, Polaris catalog. I'm gonna kind of also highlight something really important to understand is that just because you support REST catalog doesn't mean you can do everything. So, I'll go away from the menu analogy for a moment. Just basically, there's like a list of things that you can create. There's a list of operations in the REST spec, right? That allow you to read to a table, write to a table, whatnot. But you still have to implement them. So like, for example, Unity catalog doesn't implement every endpoint. Because if you're familiar with Unity catalog, what it does is that it takes your Delta Lake tables and allows you to broadcast Iceberg metadata. So they only implement the read endpoints. So I can use it if I connect via the REST catalog connector to Unity, anytime I read a table is going to work fine, but I'll probably get an error when I try to write. Okay, so again, just because something supports a REST catalog doesn't mean they've implemented every endpoint that's in the spec. So one of the things you have to kind of always like be wary of is like, don't assume just because I can connect to it, I can do everything. Every catalog is gonna, may eventually implement all of them, or sometimes depending on their needs, may not need to implement all of them.
Is it just because like Unity doesn't support writes on Iceberg?
Correct, yeah, because it doesn't natively actually hold Iceberg tables, it's just broadcasting those Delta tables as Iceberg. So
That's the one thing is like maybe this one I'm not getting like broadcasting Delta as Iceberg. I think it still reads and supports the Unity catalog, the native Iceberg table, right?
basically what's happening is with Unity catalog, if I write like a Delta table, Unity catalog will then write a separate set of metadata for that same table in Iceberg. But that table is only for read-only purposes because it doesn't want to have to it gets complicated if I have to try to keep these two metadata synced from writes from both ends. So will they eventually support that? I don't know. I don't know what's on Databricks' roadmap, but that's the idea there. The idea is just it's a way for you to access the Iceberg only tools with your Delta tables. That's the idea. But the grander point is that you don't have to implement every endpoint on the REST spec. So when you see that a catalog supports the REST spec, you still want to kind of read up on what level of support they have for it. Okay, there are going to be varying different levels of support.
So it looks like a simple way to implement this open API spec. The same way Netflix route, why other companies are not following the custom implementation of the catalog.
Oh, say it again?
Yeah, so what is your guidance on, implementing REST catalog service, custom REST catalog service?
Over like an internal custom catalog?
Yeah.
I mean, I don't have any particular guidance. Like the spec itself kind of tells you what you need to make sure is there for each endpoint. So it not only specifies, hey, these are the endpoints, but also like, hey, what needs to be in the headers, what needs to be.
Yeah, a bunch of endpoints, right?
Yeah, so I mean, if you implement them, you'll be able to connect to any tools. As far as like what you want additionally in your backend, actually here's another
Do
good.
you support like a lineage or anything?
Well, those would go outside the scope currently of the price. So this actually brings us to a really good point. So the REST spec only covers right now, essentially think of it as like read, write operations on tables. Does that mean that that's the only thing your catalog implementation can do? No, but anything beyond that would fall outside the scope of your REST catalog connections. So, you might still have like API endpoints to do other things like maybe generate lineage or generate like governance rules or things like that. But those endpoints won't have be accessible through like standard SQL across every tool. But that's fine, because typically I'm not going to like 50 different tools and doing governance. It's usually a tool that I'm doing the governance on, and then that's being applied to where everyone's querying it. So that specific specification handles a very specific table level operation scope. Will there be other specifications, either from the Iceberg project or other projects that handle other types of operations in the future? Or will that REST spec expand its scope? Possibly. But for example, like Polaris catalog has API endpoints for managing the catalog. Those fall outside of the REST spec, but I can use those endpoints to like create a catalog, create the namespace, whatnot, set rules, create users. But the endpoints for the REST spec, so that way I can read and write tables and run SQL across all these tools, are still there and accessible by any tool I connect to. So I wouldn't say that, I wouldn't limit what your catalog does if you're getting a custom catalog to just the REST spec. Just know that, hey, the REST spec allows me to read and write, but if I want other functionality, I can add that there too. It just won't necessarily be accessible from all my tools, but probably you don't need that. You would just probably build like a CLI tool or something like that for like that, those catalog management type considerations. So does that provide clarity? Okay, cool.
Another question.
Yep.
On the catalog, so you said extensible spec.
Yeah.
Where you do table maintenance like expiring snapshots.
Yeah.
Compaction.
Mhm.
Removing orphan files. So is that the responsibility of the catalog implementer? Where does
Oh,
that?
what happens in the back end?
Yeah.
Yeah. Basically, what the catalog does once it receives a request is totally gonna be based on how the catalog implements it. Now, things like doing, maintenance operations, a lot of that time you're just creating a new snapshot. So it's just updating the catalog snapshot. Like there are discussions about doing more on the server, but the main thing I'm aware of is mainly scan planning. It's like the big thing I've been hearing of. And now, yeah, which is really cool. I love the idea of scan planning. So just so you know what this means, okay, and then I won't go any further into the weeds in this. And then I'll open it up because I think we're at the end now. But the scan planning proposal, and I think I'll just leave it at there's a scan planning proposal. But essentially what this would do is that normally what would happen is I would ask the catalog for the metadata. It would tell me what the metadata.json is, and then the engine would take it from there. So it would go through the metadata, discover, hey, these are the files I need to scan, right? But the scan plan proposal says, hey, you know what? Instead of letting the engine go through the metadata, how about I have the catalog do that? So the catalog will go through the metadata, figure out the whole scan plan, and then just return the list of files.
Like doing one more activity for the catalog, not just.
Correct. And then I think a lot of things are moving in that direction. The catalog's gonna end up doing more and more over time. Why? Because if the catalog does it, then it's just one less thing that every other engine has to think about. And it's one thing that can be portable. This opens up some interesting implications or possibilities. I won't get too into the weeds right now, but it's really cool. There's a lot of really cool proposals. It's again, sign up for the dev list. It's really fun to read. But that's what, so the big takeaways I want you to take from this is, again, what's a lakehouse? So again, a lakehouse allows you to kind of operate with one sort of central copy of your data on your data lake. 2, Iceberg. Iceberg is one standard, one table format that allows you, that enables that does that through that metadata tree. Iceberg heavily revolves around that idea of a catalog to discover those tables. And catalog support is now a lot better because there's this REST catalog standard that makes it where the same connection can work across multiple catalogs. You can have this ecosystem of catalogs without creating all these weird bottlenecks for what tools you access. It simplifies what used to be sort of a weird bottleneck in the past. And because of that, you can now see a bunch of innovation in catalogs, and you're starting to see that. Okay, you see things like, if I go back to the list of catalogs, like Polaris catalog are back. Okay, you'll hear some more discussion about that in the next one now. So that way your governance rules are the same no matter what tool you're using. Okay, like Nessie brought together like catalog version, be able to do like get-light operations on your tables. I'm not as familiar with Gravitino, but I'm sure there's some cool stuff there. And again, I already talked about Unity a little bit, but each catalog is kind of bringing different things to the table. Okay, and because you don't have to worry so much about connections, like you just focus on trying to build you the best catalog possible. And that's awesome. And that's why it's really exciting. Now, again, if you want to get hands-on with like Iceberg and catalogs, these are some tutorials that I've written that you can literally spin up some Docker containers on your laptop and just get hands-on and actually see like the metadata, get really hands-on with all this. So there's that picture there. And this is a Slack community that I run for data lakehouses. So that's there. And And I think that's the last slide. Oh, and this is a calendar where you can find any event that I'm speaking at, because I'm constantly like all over the place. So that's a calendar you can subscribe to, and you'll always know where I'm at any time. Again, all these slides, this is all recorded, so this will all be on YouTube. So for anything you didn't scan, you can scan it there. We'll send it to you, but I'll open up to questions for a few minutes. Everyone have time? Okay, I'll take like 1 or 2 questions, and then we will go on to the next presentation. Any questions? Going once?
Since the spec covers data access, does it also cover the RBAC? I know you mentioned Polaris and that's probably coming, but the spec also covers RBAC.
No, because governance is outside the scope of the table format. So the Iceberg specification only covers what is a table, how do I interact with that table? While RBAC could really cover like, hey, how can I access this group of tables or whatnot? So that's really going to be more of a outside of the bounds of table operations and more in the bounds of catalog operations, which would be outside of the REST spec. That might change. So maybe the REST spec eventually does add catalog operations, or maybe there's just a whole separate standard for catalog operations that gets developed in the future. It's probably too early for me to kind of say what that direction that would come in. My prediction would probably, in the end, different types of operations will have their own different standards, and that's good, because those standards need to continuously evolve. And I'd rather have like 3 different conversations going instead of like one big conversation with a lot of different standards having to like move slowly because all the conversations are going on in one place. So
what do you see in the future, like this catalog will evolve into supporting data governance, lineage, like Unity today supports lineage, I believe?
I think you're gonna hear a lot about that in the next talk, but I would say there are conversations right now in the Iceberg spec about lineage. I think if I remember, it's like mostly like row and column lineage. But you're gonna see definitely, I would say, all that kind of observability and metadata stuff that you would want across all your tools. And I think Iceberg and data lakehouses really solve that problem, because now that your data exists outside of your tools, it'll be much easier to see what your lineage is across tools, because you can see that in the metadata. So I do think it'll eventually get there. Now, again, is that going to be natively in the Iceberg format, or are tools going to take advantage of the Iceberg metadata and create things around it? We will see. But I would assume that eventually, like all sorts of different types of observability, governance, and whatnot are going to end up becoming no longer the foray of the engine, and either in the catalog or in tools around that, because then it can capture stuff across engines, which is really exciting. I get a little excited about this stuff. But with that, again, I want to say thank you guys for coming. And I want to bring on Yufei Gu to come do our next presentation. So come on up. I will unshare my screen and you'll be able to share yours. I'll leave this here so that we can keep recording. And thank you all very much.
Hello everyone. Do you need any rest? Or we can just get it. Yeah, we can just get it started. So first, I'm Yufei Gu. I'm a software engineer from Snowflake. I'm also Iceberg PMC member. And over the past 1 decade, I worked on a bunch of open source projects like Hadoop, Spark. I'm also a Hadoop PMC back in Clara days. Today, I'm going to present Apache Polaris. I feel like Alex already talking a lot about REST catalogs. Unfortunately, I'm going to tell you a little bit more scary story about this REST catalog. So before we getting started, I'm going to ask you how many of you use Iceberg in your production, or how many of your user use Iceberg in your production? Not many. And think about one of the most kind of a scary incidents to your Iceberg table. What would it be that? Like data corruption, probably is one of them. And then table corruption. Let's say the table is totally unavailable. So about a few years ago, it's a Friday afternoon. So I got a ping by one of our users said their table's metadata.json file is missing. So something like this. So I immediately realized it's really terrible situation because the whole table is not available. You cannot read the table, you cannot write the table, you cannot get any information out of that table. And the worst part is you don't know where it's problem. It could be from the server side, the catalog server side, or it could be from the engine side, right? For example, server side could be some log unexpected kind of the timeout, then it causes some issue. And one of the thing for traditional Iceberg client is it take too much responsibility from the when you do a commit. For example, it has to every time it do a commit, it have to first write the metadata.json file. Next slide. You have to write the metadata.json file, then it have to log the table for example, for the Hive pedestal, right? Then it has to prepare all these table properties. Then it will call alter table commands, Hive command, to swaps the metadata.json file location for that particular table within the catalogs. Then it will unlocks table. So anything happens between them potentially will make it fail. The commit will fail, and even worse, there's a good chance that it will cause inconsistent for that table. That just happens. The table is corrupt. So the community, I think Alex already mentioned a lot about the REST catalogs. So the community come up with the solutions, REST catalogs, no surprise, already talking about. So other than a lot of responsibility from the client side, we actually take a lot of certain responsibility from the client side to the server side. So server hands the commits, which is more reliable and faster. And server write the metadata.json file instead of the client side, which fix the client compatibility issue. For example, if you have two clients, one is Flink, one is Spark, and one is with old Iceberg version, with one is with the new version with a new field within the metadata.json file data file, right? So every time your old clients write the metadata.json file, of course, it will remove all this new stuff from the new clients written by new clients, which break that table. So the server-side metadata.json file writing eliminate that kind of issue. So you get a consistent behavior for your table.
So server, you mean the catalog server?
Yeah, catalog server.
So previously, like, well, until today, is it like, say, when I use a glue catalog, you mean to say, if I use a Spark, Spark is accountable for all the writes?
It's mainly, I'm actually not so familiar with Glue, so they're quite keeping evolving. Glue also adopt the idea of the REST catalogs probably recently, which I'm not sure. But for the Hive metastore, it's definitely that types, right? Other than that, it provides better support for the multi-language clients such as Python, Rust, and Go. If you are use machine learning use case, use Ray plus PyIceberg, which for quite a long time, the PyIceberg only support the REST catalog. And that's pretty sure the same story for the Rest and the Go. Of course, any other clients, if you want to build by yourself, this is the standpoint always the best choice right now. Other than that, I think we've already talked about the advanced feature for the catalogs. Multi-table transaction is not possible or really hard to do without REST catalog because it can easily run into the deadlock if you just let client side to the locked table. And the server-side planning, as Alex already mentioned, which is very exciting feature for the REST catalog, only possible. So you see the trends. We try to move more and more stuff into the server side, and takes the responsibility from client side so that client can keep lean and the engine can focus on its own job.
So all Iceberg risk catalog supports multi-table transaction, or is it Polaris?
The API is there. It's still up to the like any particular implementation to do. It's not all of them supports the multi-table transaction.
But that Polaris supports, no? Is it?
Polaris is yeah, I'll get to that a little bit later.
Okay.
Yeah. So unfortunately, like the Iceberg itself, this product itself does not provide an implementation for the REST catalog. So today I'm gonna introduce Polaris, which is developed inside Snowflakes and donate to the Apache Software Foundation. Right now it's in incubating. So Polaris is building for the production-ready REST catalogs, Iceberg REST catalogs, with a bunch of the enterprise feature. Let's take a look at these features. First, Polaris is 100% compatible with the Iceberg REST catalogs. So you can bring your open source engine, Spark, Trainer, Flink, or proprietary engine, Snowflakes, or your own engines if you want to build your own clients to access Iceberg table. As long as all these engines or tools are compatible with REST spec, they can all talk to the Polaris. So specifically, it's called all these APIs, configuration APIs, namespace API, table APIs, as well as the latest view APIs. And then for authentication, it is for the standardized OAuth 2 authentication. And it also supports multi-catalogs, which I'll get to that a little bit later. This multi-catalog is not a concept within the REST, Iceberg REST aspect, but it's very useful feature. I'll come to that a little bit later. And other than that, the Polaris also supports multiple realms. I'll come to that a little bit later. So if you use the catalogs, it's actually not only about how your engine to connect to your table. It's also about how do you manage your data, your tables, namespace within the catalogs. So these two features are role-based access control and credential vending are my favorite feature within the Polaris. So with a role-based access control, you have the centralized place to apply all these access control on these entities within the catalogs, namespace, tables, views. And before credential vending, if you ever talk to the Iceberg table with your engine, you have to set two sets of the credential. One is for catalog, and another is for the storage, S3 AWS credentials, right? The other credential like HWS or GCP credentials. And with credential vending within the catalogs, we combine these together so that you only need one place to set up all these access control on these tables, views. For example, you only allowed read only for this particular user for the tables, right? With that setting, it will automatically vending the credential, S3 credential for read only for that particular S3 location of that table, which is very powerful. Of course, the Polaris is also built for microservice, which you can run anywhere with Kubernetes cluster or single nodes, AWS, Microsoft AKS and GKE in GCP, or your private Kubernetes clusters, as well as like Snowflake provide and manage the Polaris as well. So these are like the previous the high-level features. Let's dive into the detail within the Polaris. Within the Polaris, you can create multiple catalogs, and there are two types of the catalogs. One is internal, which you can read and write, and this is very useful if your team is support a big org you want like multiple big orgs, right? Then you want a user to separate their entity tables namespace. So you can create one catalog for each org, and they are separated. And it also supports the external catalogs, which you can export a table from the other catalogs, root catalogs, have meta store, so that you can manage these, access these tables from Polaris. Right now, it's read only. And the namespace can be nested arbitrary deep within the Polaris. And under the namespace, there's tables, views, which is a standardized REST spec, Iceberg REST spec. Here's a permission model within the Polaris. There's three concepts, sorry. Principal basically is the identity for applications and users. And catalog roles is a group of permission on entities named namespace table of views. And the principal roles is a connection between the principal and the catalog source. So if you look at this diagram, there's two catalogs within the one Polaris server, and one catalog. Each catalog is have three different catalog roles. Admin has most privilege to access the entities. Right now, it's all point to the namespace, but it's not necessarily that way. It can point to single tables, views, and you can create multiple namespace as well. And data admin, which you can read data, write data, list tables, namespace, and the read-only catalogs roles only support read-only use case. Then we have these blue box, which is principal roles to group these catalogs from multiple catalogs. Then, for example, here we have service admin, which has admin privilege for all, like both catalogs, and data engineer, which has the data admin role catalog role for these both catalogs, and data scientist, which has the read-only roles. And then you can assign these principal role to your users. Here, Alice is an admin for both catalogs, or your applications like Spark for ETL and Flink for streaming. Or you can assign these read-only principal roles to, for example, AI, ML applications. This is how Polaris manage these permissions. And so much for the features. We also make it super easy to use. I'm gonna do a live demos to show how easy to try Polaris in just a 5 minutes. First, we're gonna clone that from the repo. At the same time, so I also open another terminal. Then we've already downloaded Polaris, then go to the Polaris, and then we just run application, which will compile the Polaris. At the same time, we bring up one Polaris server with in-memory database as backend and the local file system. Okay. Here, I'm gonna use Spark executor to connect to the Polaris. What it does is first, it checks if you already have the latest Spark distribution. If not, it will download, then set up a Spark applications, then creates new catalogs within that server, within that Polaris server. Then it will fire the Spark execute command line. Right now, it's all working well. If you look at this one here, we have already created new catalogs within the Polaris server. Then we can use Spark executor to show that First, I'm gonna show the catalogs, which is the Spark catalogs within that Spark applications. We see Polaris catalogs already there. Then we can create database. And we can show that database. It's there. Then we create a new table. And that all works very well. And we insert some value to that table. All right, working well. Then we do a selection from that table. All right, all works well. And let's try if we can call a procedure. Say one of the most used procedure is the expire snapshot. We gave the table name, table identity, and time step. Give it more like. All right. Yeah, it works. The procedure works, but it does not do anything because we only have one snapshot within that table. So what we can do is we create a new snapshot by insert a new row. So we can double check if that new snapshot has been created from the all right, so you can see two snapshots here. Now we just expel the snapshot. Cool. You can see one snapshot has been expired, and we do that select again. All right. We only have one snapshot right now. Yeah, that's the demo. That's how easy you can try out the Polaris. Yeah, this page basically is seeing what I've done in the demo session. All right, as you can see, Clara is already getting awesome, very solid foundation. So what's gonna be next? We don't stop there. Here's a community-driven roadmap for Polaris. First, when we talk about synchronization between multiple catalogs, right now it's manual, right? We want to make it automatic. So this is working process by notification API, which is not a part of the Iceberg REST API. It's a kind of a catalogs API. And the second, we want to, right now it is supported 3 major storage. All the storage on the 3 major cloud providers, S3 and Azure and the GCP's object storage. And we want to support more, which like HDFS is still quite popular in some companies. Then we can support the other data types like type or even like volume, right? And more data governance features, which is quite common request from the catalog users. Lineage, it's already discussed a little bit. And current masking encryption. The other advanced Iceberg catalog feature like multi-table transaction, which is working in process. There's PR number there if you're interested to check that out. And the rate limiter, it's kind of a standard server feature. It's working in process. And commit conflicts resolution, which is used for resolve the maintenance commits as well as ingest commits, because we always wanted to prioritize the ingest commits over the maintenance commits. And the server-side planning, as we already discussed. Migration tool for the heavy metal store users. Like we know that I'm come from my previous company is Apple, so heavy metal store is actually quite widely used within the company. So in case of the migration, if they want a migration from high store to the Polaris, we manage some tool to help you doing that. And that's amazing Polaris catalogs. And right now, Polaris is in incubating. The Polaris had got 8 PPMC members from the leading organization like Snowflake, Gmail, Google, Microsoft, AWS, and Confluent. And you can be part of the innovation. You can contribute to the cutting edge projects with a strong community. Also, if you want to get involved, you can engage us with the dev list as well as the chat channel. I'll share this resource a little bit later. And you are more than welcome to contribute to the code base as well by adding new features, bug fix, or document enhancement. Right? All right. I'm open up for questions.
So questions, right? I think so. The way when you looked at the catalog, so generally it used to be three parts, right? Now, should I say instead of schema in Polaris catalog, we have n number of namespaces?
Namespace is, as far as I know, it's only supported by Polaris, but it's a part of the Iceberg REST catalog. So as long as you compatible with Iceberg REST catalogs, it is analyzed arbitrarily nested.
So it's like I'll be using a.b.c.d. So that eventually goes on and on.
Yeah.
Okay. And the second part is, let's say I already have say like a Iceberg tables in Glue or say like a Nessie catalog. Now, if I want to move into Polaris, is it like a seamless or it has to be some conversion effort from A to B?
Yeah, it could be some conversion for effort, but it's not from the engines, right? It's from the catalog itself. Like you of course you have to move this part of the tables or this metadata from the one catalog to another, right? But from any side, it should be seamless. Yeah.
So it's not like an open metadata standard that makes the.
Yeah, it's basically first it's 100% compatible with Iceberg's REST spec. So as long as these engines with it's all fine. No matter which catalog you can connect to, right? Of course, you still have to figure out first like authentication. And right, authentication is a little bit tricky in terms of each organization might has its own authentication, but Polaris support that you can plug in with your own OAuth 2 authentication, right? That's the story about authentication, but otherwise it should be fine.
So how about the other way? I mean, from Polaris to Glue.
Yeah, that's a good question. So from other way, if that is REST catalogs, the same story. If it's not a REST catalog, then it's probably a little bit harder.
Yeah, because not all catalogs are REST catalogs yet.
Right.
Eventually they will be, they might be.
So
But
that's
up
why
until then-
this roadmaps, we can sync the Polaris catalog to another one, right? To another catalogs by this notification PI. So to support the search kind of the use case. I don't think this is a very popular use case, but it happens, right?
So you showed the credential vending part,
Right.
right? So let's say if I drop this service onto, or say for example, AWS or any other cloud. So is there any caching mechanism for credentials that you went, and what is the backend for your data store in this case, right? So you're not running any high meta store.
Right.
Is it JDBC backed, or can I plug in any data store for that?
So first, the credit funding has to implement per vendors, S3, Azure's GCP's over storage. It's kind of policy game. Like you play with these policy game, you gotta assume role from that particular.
No, that the open source has that implementation, or you only have the interface defined?
The open source defined the interface. Right now, it's we just have a discussion with Edward from Databricks to standardize the credential part for all these popular object stores, S3 related stuff. Right now, it's standardized, but it's on the REST catalog comment session. So it's not it's kind of a schemaless, like key value pairs.
So where you showed the multi-catalog, right?
Yeah.
So is it the multi-catalog is something that you showed within your namespace type, or can I have like, let's say that I have two different catalog services that I run, and based on the input comes in, I go to catalog one and catalog two, completely two different.
If you're talking about two different Polaris instances, that as I understand it, it's not necessary. Right? It's different route, right?
Yeah.
It is part of the REST spec. So different catalogs, when the client try to connect to the different catalogs, right? It will configure one items called the warehousing. The name is a little bit funky, but it is actually the catalog names. Then the server side will send back the configuration endpoints result, which have the new endpoints can connect with the old standardized path. So that when you talk about two catalogs within the one server, you actually use two paths.
Thank you.
Yeah. All right.
Okay. Thank you.
Yeah.
That was wonderful. We got to see a nice live demo. Okay, and again, Polaris is open source, so you can go and try that at home, and I encourage you to do so. With that, again, just a reminder that these cards that are on the tables are for entering the raffle. They'll be at the end of the night. If you haven't filled one out yet, fill one out. Try to fill it out during this next presentation, so that way I will collect them, any remaining ones at the end. And then again, we'll be auctioning off some Starbucks gift cards, a couple of copies of the Apache Iceberg book. But let me get this sharing, and we're going to get our next speaker on board with Waymo Liu talking from PuppyGraph.
Feel free to help yourself to more food or drinks too. There's plenty to go around. Don't be shy.
Okay, and again, here is Waymo Liu from PuppyGraph. Now, PuppyGraph is a really exciting company because you've been hearing us talk about SQL queries on your storage all evening. Now, Waymo's going to tell you about how you can run graph queries against those same Iceberg tables, basically allowing your Iceberg lakehouse to be a multiple database, which is amazing. So here you go, Waymo. Have at it.
Hi everyone, I'm Waymo from PuppyGraph. Actually, before the product is really related to my work experience. My first job is in a graph database startup, but then I realized the problem is that it seems the mission of the graph database is to beat and replace the SQL database. Then I realized that this may be mission impossible. So I joined Google because it's a safe choice and work at a unified SQL query engine called F1. And then the unified SQL query engine can query all the data format and also the data sources inside Google. And almost every Googler is using it, including the marketing people and the sales people. I realized that why we can just have a graph query engine can query similar to that. But the problem is that Google have all the standard inside Google, like we have a column-based storage called a capacitor, but then I realized that in the open source world, there are some similar things. Like Parquet file is almost exactly the same as a capacitor when you for the usage. And also we have a SQL query engine to query it. And then after the Iceberg is more popular, I contact with the community leaders like Daniel Weeks and Tomer from Tabular and Vimeo. Everyone is welcome that another type of engine can query the same copy of data. So the Iceberg data can no longer only queried by SQL, but with multiple data models. Graph is an example, and I bet that maybe in next couple of years, all the data model can existing on top of Iceberg. So you only need one copy of data to do analytics in your company. And we can see the main points of a graph database. Since it's a high cost data ingestion and scalability and performance. This may sound very familiar because it's also the pain points of a relational database. And Iceberg solved this core problem solve this problem perfectly. And especially for the data ingestion. If you want sometimes when you change your mind to for the schema design, you need to redo the data ingestion and write all the data again. This is almost impossible when the data is big. So we just leverage all the benefits of Iceberg. And to satisfy the user who see the value in graph data analysis, but don't want another data step, which may be a disaster for the data infra team. And thanks to the Iceberg community, we can make the graph analytic with 0 ETL and scalable to petabytes data and billions of nodes, and also deploy to query in 10 minutes. Oh, this is also thanks to the rest of the catalog. Without that, it's super hard. But now, like Polaris catalog, you only need 5 minutes to set up, and now you can have additional 10 minutes to have all the graph ability which provided by graph database. But the graph database setup and the data loading job, ETL jobs setup may take weeks, even months. And we can see the benefits of graph before we made a meaningful investment, rather than have the budget first and then try what graph can bring, what value graph can bring. And also, we can finish the complex query in seconds. And I will show some real example later. Currently, we can have 8 hops query, like graph traverse with 8 hops query, with billions of nodes and edges in 10 seconds. And now we support the query language, which is Gremlin and OpenCipher. Both of them are open source. And of course, because we are 100, our target is 100 compatible with them. So the existing client library like Java, Python, JavaScript, and Go also supported. And this is our architecture. I think this must be very familiar with all you guys, because we're trying to follow the same pattern which graph data warehouse has. Like when there is a Gremlin or OpenCipher client, which are 2 most popular graph query language. And we will do the parsing and generate a logical plan. And for different storage, we will generate a different physical plan to have the best performance. Now we also support, additional to Iceberg, we also support to PostgreSQL, because some of the users, they do everything in PostgreSQL. But when the data is larger, they are trying to migrating an OLAP job into Iceberg and have a CDC between them. This is a typical architecture user want. Like before PuppyGraph, when you have a graph database, you need to load the data from data lake or some other SQL data source. But the problem is that if your data is not the ground truth and is not used as an operational database, the loading data from somewhere else, then the transactional features like ACID won't be that meaningful, but at the same time, it will affect your scalability and the performance a lot. But with PuppyGraph, the architecture will be pretty simple, like everyone have a SQL database and then do the ETL and the CDC to the data lake like Iceberg. And then you can just connect with PuppyGraph to the data lake and run the exactly same graph query language. So it's a kind of a drop-in replacement, but remove all the ETL pipeline. And here is an example like you want to ETL the Postgres data to Iceberg, and then you can use SQL to like Snowflake or Dreaml to query the data as tables. But at the same time, the same copy of data, you can query it as a graph. So this is another big difference than the graph database. When you load the data into graph database, you can no longer use SQL. Then it will make the learning curve super steep. Because everyone is more familiar with SQL, and they want to use the familiar thing as much as possible. Now you can have one query script. The first statement is SQL. The second is the graph query language. And then the third one may be SQL again. Or the fourth even maybe Spark jobs and the different things. Then your output can be all input, and all output can be other inputs as well. And then I will explain why Iceberg is the ideal case to do the graph analytics. First is that is a zero ETL. So you don't need to have two copies of ground truth data. It will bring more complexity to the system. And even a lot of users have graph use case, but they reject to have another database because the ROI seems not that meaningful. So they just miss the first try of graph and see the benefits. And also, with Iceberg is super easy to deploy. Like you already have all the data there. You just need to let us know which table is the type of vertices and which table is the type of edges. And also, when you can change the schema whenever you want, because one of the customer gave a name to the feature. It's no longer schema on right, it's schema on read, which means you already load the data there. You don't need to design the schema and then load the data and write the data. Now, before you run the query to reading data, you can give a schema for that. Another benefit is the column-based data file format. Because graph database have to be row-based, because they need to adding, updating, or removing vertices or edges and make it transactional and support ACID. But then the problem will be if you have 100 views for vertices or edges, you need to load all the attributes into the memory. Even it's a home address or picture, it's super easy to slow and auto memory. But now, because it's a column, Iceberg itself, most data in Iceberg is already column-based. We can, for a query, maybe only access 3 or 4 attributes. We don't need to access the unnecessary data. And all the data in memory is necessary. So we can make it much faster and also much more scalable. And but what is the difference of the graph query engine and SQL query engine? Since SQL query engine is definitely optimized for SQL query, but for the graph perverse query, the basic operator is no longer aggregate, join, table scan, something like that. We define 2 operations. One is the vertex edge option, another is the edge option. The vertex option's input is a collection of vertices. The edge operation input is a collection of edges. In this way, any graph query can be generated a plan, which is a combination of edge action and vertices action. In this way, you can have the optimized plan to only fetch the necessary data and also cost-based. And another benefit is that most graph databases are not distributed. And some of them are distributed, but can only improve the QPS. But for one single query, you cannot have more machine to make it faster. But what we are designing that because Iceberg itself have almost a limitation of data size. So we are another query engine, which is the distributed design, more machines, better performance. The final benefits, this is our new design based on the requirement of our customer. Because they want to do some anti-fraud things, they want to have some data in real time. But it's super hard and costly to make the entire Iceberg data set in Iceberg to return query in real time. So we have some strategy like 10-day data in cache. So for the latest 7 days data, if the query only access them, then it's a return in real time. But if some query access the last year data, then it will move to the cache and then automatically turn to the offline mode. So in this case, the query will, the cost per query will be super low as what we usually use in Iceberg. And the magic number 7 can be set by users. Some of them our customers set into 30 days. And then last month's data can always have a dashboard and return in real time. And the older data, the query will automatically turn into offline mode. And what can we do with a graph model? And I have a bunch of use cases here, and let me show you some real one in production. The first one is the blockchain analysis, which is also the use case is also similar in the big banks. Like if you want to know, usually you have a table like sender, receiver, amount, and the timestamp, and A transfer money to B like $200 on this timestamp. And it's physical table. You can use SQL query engine like Dremel or Snowflake to generate reports, and also with BI tools like Tabular. But Tableau. Yeah, and but at the same time, logically, it's already a graph. In blockchain world, there are a lot of fake accounts. For example, A and B are both terrorists. They want to transfer money between each other, and then they will create 100 fake accounts, and then A will transfer money to BCD, and the BCD will transfer money to XYZ separately, and then it's a super complex network. But all the money finally goes to B, because they don't want to waste money. And in this case, it's super hard to find what's the real relation between A and B. Maybe A is already arrested, but the money is gone and no one knows where is B. But now, if you run graph query, you can easily find where the money finally goes to. And the lucky thing is that you don't need to prepare data for this to build another system. You can just query your existing tables in this case. And also, you can use some SQL query engine like a Dremel and Snowflake to prepare the data. For example, in this case, A transfer money to C 2 times. One is 1999. Another is $1. And then sometimes maybe 2 people transfer money for thousands of times and just want to consume the anti-fraud resource. And in this case, you can use Dremel or Snowflake to do the group by first. And then, this number is wrong. This number should be 2000. We can have a sum of all the transactions between the same pair of people. And after that, you will have a subgraph of the raw data. In this case, the graph will be much smaller. And no one wants to learn how to do this in graph query because it's a much more longer curve. But everyone knows how to write a group by SQL. So it will make the data engineer life much easier. Oh, this is the customer testimony from Coinbase. And they also use, but in this case, they use unit catalog on Delta Lake. And it seems based on our observation, Iceberg and Delta Lake are adopted by a lot of tech companies which have big data. And another case study is that if you have a whole graph and some of the people already labeled as bad guys, and maybe the other nodes interactive with them have a high risk to be a bad guy as well, and also maybe have the same label. Like if a frauders transfer money to another person a lot, maybe another person is also a frauder. So we can just run the whole graph or graph algorithm on the whole graph to have the influencer score to transfer to the neighbors and the neighbors. And something like a PageRank, and everyone will have a risk score. And then you can easily know, oh, this is a high risk guy. We need to verify whether he's doing something bad. And also, it's a similar thing happened in use case in industry like cybersecurity, like network topology. If you have a lot of device, some high risk device with low level security, with low security level, maybe hack first. But usually you won't care about the alert. But some of the high security level device have been hacked. Usually it's because the neighbor has been hacked, and the neighbor's neighbor have been hacked even before. And then the attacker will leverage the low security level device to hack the high level one. And then we can help them to know what's the root cause, where is the attacker beginning. And also, because most use cases have the similar mathematical model, a lot of nodes and a lot of data and entity have a relation between each other. So we can also help the customer to do the CI/CD dependency analysis, and also the workload and the error rate, and the VPC flow logs. And also we have some customer like from e-commerce company and some health industry company. In this case, it's more like because your user already have a lot of tables, and they haven't realized it's a graph. Like if you have a customer table and also a product table, and the history of click and the history of orders are actually two types of edges between them. Like if someone click ABCD, and then a lot of people click ABCD, you may have some rules, and then if you find someone like click ACD, usually they will click B, and then you can give them a recommendation. And also some other similar things happen in the patient journey, like if you have two diseases already, sometimes there are patterns, you have a high risk to the third one. And then the doctor can give advice to do some prevention about the third disease. And also the click knowledge graph. And the final topic is that recently there is a hot topic called graph rack. Of course, it's because the adoption of LLM. And one of the user use it to have a social graph. And then if someone wants to invest in a company, they can just use a chatbot who can make an intro. And then we will search for their tables and give a recommendation, maybe a list of recommendation, like who serve with the company's CEO with the same board, or something like that. And also, the challenge of LLM is the data-oriented question is a big challenge for the most enterprise to using LLM. One is because of privacy, another is because of hallucination. And like the question, what's the nice movie of Tom Hanks? And which person does Jackie Chan collaborate with most frequently? And ChatGPT will also give you an answer. Will give you answers like his Wikipedia page and other filmography resource, but it's actually don't answer the question at all. So we help them to build some graph, like dogs is animals and animal is living things based on your tables. For the previous example, we just download the public dataset of IMDb, which is interesting because IMDb dataset is already trained by GPT, but it's trained by the web page one. At the same time, they have a structured data, which is much more cleaner, like this three table. Like the first one is the title, the second one is the name basis. The third one is the have two column. The second column is the primary key of the first table. And the fourth column, nconst, is the primary key of the second table. So the titles may be animations, maybe TV shows, maybe movies. And name basis may be a producer, actor, actress, or directors. Then we already have a knowledge graph. Person, cast and crews of title. And then you can just answer this question, like Tom Hanks. .in means get the neighbor, which is the movies, since it's along the title type movies, and then ordered by the start year. And the second question will be Jackie Chan first, and .in get all the works, and .out get back to the other person, and then we can group by the primary name of all the people, which is the which are the collaborators of Jackie Chan and ordered by the count. Then it's James Xie, which collaborated with Jackie Chan 181 times because he covered the voice of Jackie Chan in animations. And then it's the benchmark. Because we don't do any, if we don't do any ETL, maybe the straightforward idea that it may be slow. But thanks to the very good design of Iceberg and Parquet file, and we can see that if three hop neighbor on Twitter dataset, the bottleneck is no longer I/O, it's about the computation. So we can be 200 to 70 times faster than Neo4j, which is the top one graph database. And we can also finish the 10 hop neighbor query on 500 million edges in 2.2 seconds. This is a 4-machine cluster. And also, we can have some example query comparing with the Neo4j. And the data is in Iceberg. And we can see that for the smaller data, the performance are similar. But when the data is bigger, the advantage will be bigger as well. Yeah. And then we also support large graph algorithm. And then you can do some community detection and similarity computing and also DAG algorithm. Yeah, this is basically the content of today. Do you guys have any questions? Yeah.
So for graph search, do you need an additional index for based on the Iceberg table? Since the matrix file only has min-max states, right?
Yeah, since the most important information we need is the min-max.
Okay.
And after that, if user can have some Bloom filter index or the sorted something they order things, it will be benefits more. But the lucky thing is that it not only benefits the graph query, but also benefits the SQL query. So it's super worthy to set this on your own data set. Because when you have too many joins, sometimes the query itself nature to be a graph query. So if you can set up the match the index, it can benefit the graph query and the SQL query at the same time.
So to read graph, you have like your own implementation. Like for example, today for an open world, we have the Rust reader, the Rust libraries or the Java-based libraries. Now, do you have your own or you just read one of them and then convert as a graph during your read process?
Since we can call the API of the read API and write API of the.
So the Iceberg spec APIs you come.
Yeah. So we can, that's another thing we want, is a big advantage is that before Iceberg, it's not advantage of us, it's an advantage of Iceberg. Before Iceberg, it's something like if we don't have a bus in computer architecture, and every two devices need to talk with each other. But with Iceberg, it's just like a bus, and every device just need to talk with the bus, and all the things connected And now we see that Iceberg is a similar thing. Everyone just need to talk with Iceberg, streaming things into Iceberg, batch write into Iceberg, and also reading from Iceberg. And then you don't need to integrate with a bunch of other compute engine or any other things. You just talk with Iceberg, and the other talk with Iceberg too. Yeah.
Any questions? Someone's going twice. And again, thank you very much, Wayne. That was absolutely fascinating. Thank you. Again, that was Wayne Mulu, CEO of PuppyGraph. Again, there's actually a tutorial on the Jeremy.com blog. If you want to get hands-on with PuppyGraph right there again from your laptop, I did create a tutorial if you want to try that out. It's really cool. A very, very neat product. I'll start collecting all these in just a moment. But just want to say again, before we start getting into the raffle and wrapping things up, I just want to say thank you guys all for coming to this open source data deep dive. We're hoping to continue doing more of these. Again, we did one last month in New York. We're doing this one here in Santa Clara. I want to just keep doing them in different cities. So one thing I want to ask you guys to do for me when you guys get home tonight is we'll send you a message from when you RSVP for the event with a feedback form. We would love to hear your feedback about what you enjoyed. What would you like to see in future events? What basically, we want your feedback to continue doing these events and continue making them better and continuing being sort of a way of building that community. So please do fill out those feedback forms when you get them. So for everyone who's listening online, thank you for listening online. We're going to be, I'm going to be wrapping up the Zoom session. And so let me I'll stop the recording. So,